started. Yay! Right. I think I'll already. I think I'll stop asking that now. Share screen. Okay, Caitlin, you doing all right? So let's get it started. Let's get it. I don't know. You all know that song? No? Okay. Right. So we're going to talk about computations and basic arithmetic in this class. It's the very first class, so we'll take it quite easy. But my question comes, and it's only the two earlier, so the two earlier are going to have a lot of talking to do. And what's going on here? Very good. That's funny. And my question is, what is mathematics? And of course, everything I write, you should write it. And as you could see, we starting from scratch. So, what is maths? So, one of my Form 3s that actually gave me a really nice answer. It's a language. Maths is a language. In fact, it's the language of number. The language of numbers. So maths, we have two things. The first thing is we have the first thing we have is numbers. And those numbers, what are those numbers? Those numbers are things in maths. So we have things like apples and pears and you know, things like measurements and how much hair you have on your head and all of them kind of things. Those are things, and those things are all things in the universe are represented by numbers, or can be represented by numbers, whether you have this number or this number or this number or this number. They're all numbers. And then the second thing in math are operations. What are operations? Anybody? Anybody? What are operations? Nobody know what an operation is? Well, but you can tell me what it is. What are they? Give me an example of an operation. Caitlin, what's an operation? Yes, that's it. We have these operations: addition, subtraction, multiplication, and division. So maths is a language, and that language comprises of two parts. We have things, which are numbers, and then we have what we do with those things. So what can we do with these numbers? Well, we can apply an action. So that is the word you was looking for. What is an operation? An operation is an action. You are applying an action to these numbers, these things. So numbers are things, and operations are what we do with those things. And hopefully, if I do my job correctly, you can see that we have 4 operations: addition, subtraction, multiplication, and division. But if I do my job correctly, I hope that one day you guys could understand that multiplication and division is actually the same thing. We could just call it multiplication. I hope you can understand that addition and subtraction is actually the same thing. We could just call it addition. So therefore, there are only really 2 operations. And then I hope you understand that addition and multiplication is actually the same thing. So therefore, it really only have one operation, and that is addition. Do you all understand how this is true? Caitlin, you ever heard this before? You never heard this? It sounds like crazy talk, right? Yes. Well, hopefully, if I do my job right, maybe by the end of when I'm ready to write exams and things, by the end of the curriculum, you will be able to see that. You'll be able to really understand it, right? So everybody write this stuff down. Are you good with this? All right. So we are going to get started now, right? We're gonna see how much work we could actually pack down today. Right? So let's start with this. First question. Right? 4 plus 3. What is that? 4 plus 3 is 7. My question is, how do you know that? All right, but how do you know that? How can you prove to me 4 plus 3 is actually 7? Prove it. You could do it on your fingers, yes. So what you're doing is you are proving it by counting, and so what I could do is I could have 4 cherries here, and I could have 3 cherries here, and I could just count them and say, well, all right, I have 7 cherries, yeah? Another way I could prove it is via a number line, where I could have 0, 1, 2, 3, 4, and I'm on 4 here. So I add 3, 1, 2, 3, and I'll end up on 7. Nice. Caitlin, do you understand how I proved this using counting and a number line? Alright. You see, we starting at the bottom, eh? We're starting at the very, very beginning. Yeah? What is 3 plus 4? And of course, we could prove it the same way, right? But where's this business now that 4 plus 3 is 7? And if I rearrange the numbers, 3 plus 4 is also 7. So what do you call that? It's one of the year, but what do you call it? Do you remember? Caitlin, you remember? Right. So when we change the order, but we have the same answer, we say that the operation of addition, which is an operation, is commutative. Please remember that. Now, of course, all of these things is things you might have forget and things that you may not even have heard of before. But at the end of the day, you might be yawning and being like, really? We really doing 4 plus 3 and commutative? You know, if you want to go and sleep or whatever. But at the end of the day, when you guys reach algebra level, this here is the problem that at a CL you're having. Understanding if something is commutative or not. You know, can you do that? So your problems from algebra, they stem from right here. Caitlin, you understand what commutative means? Alright, nice. I hope you guys writing. You guys writing the stuff down as we go, right? Okay, good. Number 3. It's 4 minus 3. prove it. Right, so if I have 4 cherries and Caitlin come and thief 3 cherries in the night, like a thief, then I'll only have 1 cherry left. Thanks, Caitlin. Right? Also, if I have a number line here, 0, 1, 2, 3, 4, you know that when you're subtracting, you will go in this direction. So you're on 4, 1, 2, 3, you'll end up on 1. Nice. So, what if I flip the numbers now? What about 3 minus 4? What is that? Negative 1. How can we prove this thing? Number line is the easiest way to do it, eh? If it is that I was on 3 and I go back for 1, 2, 3, 4, I'll end up on negative 1. Caitlin, you alright so far? You know it does get real heavy real fast, eh? So don't blink, you know. Don't blink, right? Good. Any other way that we could prove this if we didn't know about number lines? How else could we prove it? What if I have $3 in the bank? So I have $3 in the bank, and the bank charged me $4. So I owe the bank $4. How much money do I have? I have $3. How much money do I owe? So can I pay off the 4? How much I could pay? How much money will I owe then? Right. So you could look at a negative sign like if you're owing, if you're in debt. Also, look at this. Look at another thing. Right? We change the order, and we got a different answer. So therefore, subtraction is not commutative. But addition is commutative. So, if I go back to the original example of 4 minus 3, 4 minus 3 is equal to 1, and this 3, you're owing this 3, and this 3 is a very negative person. This 4, is this 4 positive or negative? So I could put a plus in front of this 4. So now I could switch them. I could put negative 3 here and the positive 4 here. And I ended up getting the same answer. So you could see here that subtraction is not commutative because we left the subtraction sign in the middle. Yeah, the 3 was negative here, but the 3 is now positive here. So this does not technically say that we change the order. No, this is not changing the order. This is a whole different question from this. In this question, the 4 is positive. In this question, the 4 is negative. So it's a whole different question. It's not like we changed the order. No, look, we changed the order over here. The 3 remain negative, the 4 remain positive. And so addition is commutative. Anybody lost yet? No? Alright, we will see. So what about -3 minus 4? Where's that one? Caitlin, what do you see? -7. Alright, so we can see here that we have many examples. Right? Let me see. Where's some of the examples we were dealing with? 4 plus 3 equals 7. Right? 4 minus 3 equals 1. -3 plus 4 also equals 1. But then we have -3 minus 4 is equal to -7. Right? These are the conditions. You see these rules here? Caitlin, I think we did these rules before. Scotia, I think we did these rules before. But for some reason, when you guys are doing algebra, you guys just forget these rules. So, please remember these rules when you're talking about addition and subtraction. The rule is, number 1, if you have the same signs, if the two things that you are adding or subtracting, if they both have the same signs. So if we look at it here, these two guys, they have the same signs. So the -3, -4, they both have the same signs. In this case, we have +3, +4, they both have the same signs. So when you have the same signs, what do? Add. So you added 3 and 4 is 7, 3 and 4 is 7. And what? Keep the sign. Whatever sign it was, you keep the sign. Caitlin, you remember this rule? You ever do this rule? You ever do this rule with me? Alright, good. So we're doing some good revision today. Alright? And what's the second rule then? What do you do when there are different signs? So if you're looking at these guys here, these guys, the signs are different. The 4 is positive, the 3 is negative. Alright, so what do you do when there are different signs? What is the rule? For different signs, you find the difference. So you keep, for different signs, you find the difference. Remember that word, different. So you check different signs, you find the difference. So the difference between 3 and 4 is 1. The difference between 3 and 4 is 1. Right? And actually, let me do one more example here. What if I had 3 minus 4? We saw that this was -1, and yeah. So the signs are different. This 3 is positive, this 4 is negative. So we find the difference. So when the signs are different, you find the difference. The difference between 4 and 3 is 1. And then what do? Yes. Of larger number. So whatever the larger number is, in this case the larger number 4 was a positive, so the answer is a positive. In this case the larger number 4 was also a positive, so the answer is positive. In this case the larger number 4 is a negative, so the answer will be negative. Caitlin, did you remember this? These guys? Little bit, yes. Well, I'm glad that I did it over, because this right here, this class is all your biggest problem, especially when moving on to algebra. This is not just you all alone, the average student. The average student has real problems with these basic little rules here, right? When they're doing the algebra, that is. Nice. So we're moving on. We're getting over. Right? What number are we on? 5, so we're on number 6. Number 6. 3 times 4 is what? 4 times 3 is what? Negative 4 times 3 is what? Negative 4 times negative 3 is what? Oh, let me change that. Negative 3 times negative 4 is what? Plus 12, eh? Right, so where's the rule here? First thing that we could notice from this is that multiplication is what? Yeah? So multiplication is commutative. Right? And the rules here are, number 1, if you have the same signs, then what? Then the answer is positive. So once you have the same signs, so if you look at these guys here, if you look at this guy here, you can see that they both have the same signs. The 3 is positive, the 4 is positive. The 4 is positive, the 3 is positive. So you'll be positive. And then even in this one, they have the same signs, negative and negative. So that gives us a positive. Caitlin, did you remember this? All right, and then number 2, when you're dealing with, and this here are the rules for multiplication. And this, please remember this, multiplication and division. People just forget that these rules here are true for division as well. Yeah? So in multiplication and division, when you have different signs, then you will have a negative answer. Right? So this is your everybody cool so far? You all write it down? Kinda. I'll give you a minute to write it down. Tell me when you're done. Nice. So we could continue with this idea right? So we can continue with this idea with what is 4 divided by 2? Right. 4 divided by 2 could also be written like this. 4 divided by 2. And what you had to understand is what 4 is. 4 is 2 multiplied by 2 and divided by 2. So the 2's cancel. And you'll have 2. What is 2 divided by 4? What's 2 divided by 4? So this 2 cancels with this 2, and I get a half. So we can see here that division is not commutative. See that? Right? But still, these rules hold for division. So if I have 4 divided by negative 2, they are different signs. Once you have different signs, your answer is going to be negative. So that will be 4 divided by negative 2, which is negative 2. If you have the same signs, negative 4 divided by negative 2, you could say that the negatives cancel. So once you have the same signs, you'll always end up with a positive. Let me know when you finish writing it. Finish write it. I have to tell a little, let me know when you finish write it. Alright, okay. Stoops, man. Okay. So, what's going on? Going on. What is that? What is this going to be? Number 7, number 8, 6. So we stop at number 6 there. So there we go with number 7 on the side here now. I hope I'll write down all of this, by the way. Number 7. All of this, even though it seems really simple and yawny, this is the problem with everyone's math. These little things here. What about this? What is 4 plus 3 bracket 2? What does this stand for? Caitlin. Why? The who? Right, so you know what you're talking about with this BODMAS thing, right? BODMAS, what does BODMAS stand for? Right. What I'd like you to know is that it's really 3 stages. The first stage is the brackets. So that's the first thing that you have to do. The second stage is your division and or multiplication. Both of them, you could think of both of them as being the same kind of thing. So you always do your division or your multiplication second. It really doesn't matter which order you do it in, whether you do the multiplication first or the division. It doesn't matter. But this is the unit. And then the third unit is your addition and subtraction unit. And this is what you do last. So what she did there, 3 2s are 6. 6 plus 4 is 10. Number 8. 4 minus 3 times 2 is what? Sorry? Didn't hear you then. Why? 3 times 2 is 6. So it's 4 minus 6, which is negative 2. Caitlin, you okay with that? Alright. Since others seem to be okay with that, then let me get deeper into it. What about this? 3 plus 2 into negative 2 minus 5. What do you have to do first? Well, the brackets already have negative 2. They have nothing to work out in the brackets. So what do we have to do now? After you work the brackets, where's the second step? Well, division and multiplication. They are both one unit. They are both the same thing. I really want you to start thinking about them as the same thing. They do have differences, yes. Multiplication is just, division is just multiplication in the other direction. Right? Addition, subtraction is just addition in the other direction. Right? So this will be 3 plus 2 times negative 2 is negative 4 minus 5. Right? And now that I have my additions and subtractions, I have 3 minus 4 minus 5. 3 minus 4. Well, these two have the same signs. So I can leave the 3 and I could just add these two. 5 and 4 is 9. And the same signs, so I keep the sign. But now these two have different signs. So what do I do is I find the difference, which is 6, and I keep the sign of the larger number. Everybody okay with that? Alright. Well, since all this so okay, since you all apparently showing off that you all are brighter than me somehow, yeah, I am very vexed by your insinuation of your intelligence, right? Right, so take these 4 questions to do real fast. So in this first one here, you have to do your multiplication and your division first. I'd like you to think about multiplication and division as being all glued together. So these three tens here are actually glued together. So you can think about them as one unit. And you could think about addition and subtraction as being separate. So this addition sign does actually separate this unit from this unit with just 10 alone. So you could think about your addition signs and subtraction signs as being separation. And then you could think about your multiplication and division signs as being a glue. So you could treat this as one unit. And the point is that you could do this in any order, right? So I could say 10 times 10 is 100, and then 100 divided by 10 will give me 10, right? I could have do it the other way around too. I could have do the division first and say 10 divided by 10 is 1. 1 multiplied by 10 is 10. So I wanted you to really get the point that multiplication and division could be thought of as one unit that gluing these numbers together, and you could literally do them in any order, right? And subtraction and addition does act like a separator. They separate your units. So your units are separated by subtraction and addition, which is why you do that last in the BODMAS. So this here, 10 plus 10 is 20 is the answer. Right? For this second one, well, somebody asked a question? No? Okay. For the second one, we're dealing with BODMAS, so we have the brackets first. So we'll have 3 plus 2, and the brackets is 1 minus 4. So you take the difference, different signs. So you take the difference, which is 3, and you take the sign of the bigger number there, divided by 2. Right? So we tackle the brackets first. And now we had to tackle in the order the multiplication and division. So in that order, we could see here that this 2 is being multiplied by this negative 3. So this here is actually a multiplication. And then that's being divided by 2. So this entire thing is one big unit. And the addition separates it from this unit over here. So I could actually do this in any order, but you know 3 cannot be divided by 2, so it makes no sense doing the division first. It makes more common sense doing the multiplication first. So I could go 2 times negative 3 will give me negative 6 divided by 2, and that will give me negative 3. And I have a 3 here. So 3 plus negative 3 is the same as 3 minus 3, which is 0. Did you guys get 0 for that one? Yeah, Caitlin? You sure, Caitlin? You sleeping? Alright. So same thing here, brackets first. So I have 3 into negative 4, is it? Divided by 4 plus 8 times 2 divided by 4. You can tell with the multiplications and divisions, this is one big unit. And I have the addition sign. This is one big unit because it's multiplication and addition. I could do the multiplications and additions in any order. So I could say 2 divided by 4 is a half, and a half multiplied by 8 is 4. Or I could say 8 times 2 is 16. 16 divided by 4 is 4. Plus, on this side here, negative 4 divided by 4 is negative 1. multiplied by 3 is negative 3. So this answer here is 4 minus 3, which is 1. You got that, Caitlin? What did you do wrong? But I did the 6 and 10 first too. 6 minus 10 gives you negative 4, right? And then what did you do after that negative 4? You got negative 4? Oh, you put 4. Oh, but you were supposed to have gotten the same answer though. So 3 into 6 and 3 into negative 10. So you do the same thing my form 3s do. You do the same thing. So if we check it, if we look at that way. No, what is this? If we look at that way of doing it, right? Oh, come on. Right. Then you would have left this 8 times 2 divided by 4. You would have gone plus 3 times 6. 6 3s are 18, eh? Yeah? Plus 3 times 6. And then plus 3 times negative 10 is minus 30. But remember, this whole thing was being divided by 4. So that means that this plus 18 and negative 30 had to be divided by 4. Is that what you did? So where's 18 minus 30? So this is negative. Is that what you got? Negative 12 divided by 4? Right, so negative 12 divided by 4 is what? Negative 3. And then on this side here, well, you still have this plus sign here. You still had that plus sign. And then on this side here, did you get 4? Well, look, we get back the same thing. 4 minus 3 is 1. So where you went wrong? Did you not get this 12? Where you get for your answer? 14.5. Wow, okay. But do you understand where you went wrong? Do you understand what I did here? You sure? Alright, school sure. You doing okay? Alright. So you see why it's really important to do these things. Yeah, it's super important to do these things. So BODMAS, just remember you do your brackets first. So 15 divided by 3 plus 2 is 5. Sorry. I have the minus here. Let me do the brackets. 6 and 4 is 10. And then 3 plus 2 is 5. And then I have divided by 25. So now I'll do my multiplication and division. So I'm seeing that 15 divided by 5 is 1 unit. That's glued together by this division sign. And then this is our next unit. This has a multiplication and a division in it. And I could literally do in any order. 15 divided by 5 is 3 minus, and then I have 10 times 5, which is 50, divided by 25, which is 2. You get 1 for this one, Caitlin? Alright, good. So I'm glad that you don't have recurring errors then. Right? Nice. Okay, so that was a little revision of BODMAS. Right? One other thing I wanted to talk to you guys about. before we move on. So this one other thing is this. What is 4 divided by 2? What is 4 multiplied by a half? Huh? Did you say something? Is it 2? You're asking me? Caitlin, what's 4 multiplied by a half? 2. So what I want to show you is that these two are the same thing. And this is where we start to talk about fractions. And in terms of the multiplication of fractions. So when we multiply fractions, when you multiply a fraction, if I have a fraction a over b multiplied by c over d, all you do is multiply your numerators and multiply your denominators. So ac over bd. So in this example here, we had 4 multiplied by a half. But you didn't realize that these are actually 2 fractions. 4 over 1 multiplied by a half. Right? And what we do is we just multiply the numerators. 4 times 1 is 4. 2 times 1 is 2. So 4 divided by 2 is 2. We could have also said 4 times a half, and what we would usually do is cancel it from here. But what we are actually doing is we are actually doing that. That is what we are actually doing. Yeah. So, another thing about fractions, when you're multiplying fractions, when you're dividing a fraction, where's the rule for when you're dividing fractions? So if I have a over b divided by c over d, what do you do here? Right. Not the first fraction, because this here, what do we call this? And what do we call this? This is your dividend. And this is your divisor. Think of it like the Terminator. The Terminator does the terminating. So the divisor, the one that comes after, that one does the dividing. So therefore this is really a over b all divided by c over b. And what do we do when we divide in by fractions? What's the rule? You invert the divisor and multiply. So therefore, this is the divisor, c over d. So I'll have a over b multiply, and I'm inverting the divisor. So the divisor will now be d over c. My answer is now AD over BC. Understand, Scotia? Alright, you forgot all about this stuff, right? It's there somewhere in the back. You're dusting off the cobwebs off of it, right? I think that's exactly it. It just have some dust on it. So this also works for our example. Our example of 4 divided by 2. Because you would have never think that this 2 is actually a fraction. But guess what? It is a fraction. That is 4 divided by 2 over 1. And so that is why when you're dividing by a fraction, you invert. So 2 over 1 is going to become 1 over 2. Invert and multiply. Another thing is when you have 4 over 2, you could think about it like if you're taking this 2 and you're pulling it out. But the 2 is underneath. So you had to have something on top. Yeah? So if you pull out the 2, it's going to become this. Everybody understands this? I'll see how well you do. I will see how well you do. Right? So we spoke about multiplying and dividing. Let me see if I have questions on multiplying and dividing fractions here, boy. Yeah, man. Right, you guys done? Alright, how long are they done now? You don't know? Was it 10 minutes? So this is actually a fraction 2 over 1. Yeah? So you can just multiply your numerators and your denominators. So negative 2 times 1 is negative 2. And 1 times 3 is 3. Okay. Same thing here. Now, these have the same signs. So because you have the same signs, you know your answer is going to be positive. So you could just multiply your numerators and your denominators. So that is 3 times 11 is 33. And what is 7 eighths? 56? Right. Yeah. Now, same thing with this one here. With 17 times 3. 51. And 9 fives are 45, right? Right. What do you call this fraction? Very good. You remember that, Scotia? And what do you call this one? So what's the difference here? This one, the numerator is bigger than the denominator. Huh? And this one, the denominator is bigger than the numerator, right? So how do I change an improper fraction to a mixed number? I have what? 51 over 45. Oops. 51 over 45. This is an improper to a mixed number. How do I do that? No, you divide, you had it right the first time. You divide your numerator by your denominator because your denominator is the divisor. It is doing the dividing, right? So it has no inversion here. So you divide it 45, 51 divided by 45. Well, 45 can only go into 51 one time, and then what is the remainder that you'll have? 9, eh? Is it 9 or 10? No, wait. No, sorry. Was it Where's the remainder you'll have? 6. Yeah, so the remainder will be 6. Sorry, I just had a elderly moment there. So the the remainder is 6 over 45. Yeah? So that is how you change improper fraction to a mixed number. What if I had a mixed number, let's just say 7 3/5? How do I change that to an improper? Yeah, so 7 5s are 35, 36, 37, 38. So that is 38, and you keep your divisor 5. Caitlin, you alright? Right. Now get into these 3. This is a simple thing. You invert and multiply. So minus 1 over 9 multiplied by 2 over negative 1. Remember, they're both negative, so your answer will be positive 2 over 9. Right? Over here, this is negative 1 all over negative 1. Right? So this is the fraction here. Sorry, not negative 1. Blah. Negative 1 over 1. That is the fraction here, because it's negative, right? Multiply by your invert 3 all over 2, and you just multiply numerators, denominators, so you have negative 3 all 2. I hope that you guys got this. Caitlin, you getting everything right so far? Nice. Same thing here. They're both negative, so you could expect the answer to be positive. So I'm going to have negative 2 over 9 multiplied by negative 2 over 3. So you see I inverted here. Even though the negative 3, even though the negative is front of the 3, because there is a negative there, means that the entire fraction is now negative. So that is why it doesn't really matter if I put the negative in front of the 2 or I leave it in front of the 3. Just having the negative there alone means that the entire fraction is negative. Yeah? So it doesn't matter where I put the negative on this fraction here. What matters is that those 2 negatives will cancel out anyway. So 2 2s are 4 and 9 3s are what? 20. 9 3s are what? 36? 27. Oh gosh, sorry, I've been going at it. Yeah, I've been going at it since like 9 this morning, so I'm almost pushing 12 hours right now. So yes, I apologize. Right, this is normally happen in the CSEC class. I just be an old man in the CSEC class, right? Nice. So when it comes, so we saw here that, and I hope you guys wrote this down. Did you guys write this down? I hope so. Yeah? Caitlin? Right. So you see how I wrote down this, you know, in an algebraic kind of way using letters. So this here is a generalization. This is one of the many uses of algebra where I could actually create generalizations. So this here too, I used a generalization. Yeah. So my question is, when it comes to adding fractions, can we form a generalization that will work for all fractions? So if I had A all over B plus C all over D, what is the generalized form? How do you add two fractions? What do you have to do? Well, how do you make sure they have the same denominator? Well, that's an interesting thing what you just said there. If you have, say, 1 on 3 plus 2 on 3. They have the same denominator. So that means that you could just keep the denominator and you could add your numerators, eh? Right. So once they have the same denominator, you're good to go. But what if they don't have, like in this situation here, what if they don't have the same denominator? So watch, the generalization for the same denominator would look like this. A over B plus C over B. And seeing what I do there? They have the same denominator. So your denominator is going to be just the B, and you add your normal A plus C. Yeah? But my thing is, what if they don't have, so 1 over 3 plus 3 over 4? What do you do to add those? Right. Now, of course, does this have an LCM? Right. So, even though you're doing the LCM thing, forget about the LCM thing. To me, it have one method that does work for everything. Whether you have LCM or not, whether you have multiples or factors or not, it have one method that is work for everything. And what is that method? What do you do when they don't have an LCM? What do you do? Yes. So you see the multiplying 3 times 4? 3 times 4. And that multiplication thing is some serious business. That, whether you have an LCM or not, the multiplication of the denominators will always work. Right? So now that I multiplied my denominators, what do I do now? Caitlin, I'm not hearing you. No. And this here is the problem with fractions. You have some cancelling off to do, eh? This here is what is give earlier all of the algebra problems. All of your problems in algebra starting right here. Because if you don't know how to add these two fractions, then how are you going to know how to work it out when it have x involved? Well, guess what? When x is involved, there is no difference. You work out your fractions the exact same way. So Caitlin, how you just add two fractions here? Come on. You could put how many times the 3, which 3? It have 2 3s here. This denominator could go into the 12. Right? So how much times this could go into this? Huh? No, how much times this could go into the 12? 4. So you can kind of see that this could cancel with this and you'll get 4, eh? And then what do you have to do with that 4? Multiply by the 1. So you get that. You remember the Scotia? Right? And then you had to take the 4 and see if you could cancel into the 12. So 4 into the 12, well the 4's cancel. So you'll have the 3 remaining. 3 times 3 is 9. And? Scotia, you alright? Right. How do we generalize this though? What if I told you that there was an easier way? Check the easier way. Just now, I think again. Okay, it's not alcohol. So yeah, it is good. Check the easier way. And this will work for all fractions, right? You multiply your denominator. So 4 times 3, 4 3s are 12. And what you do is you just cross multiply like this. So 3 3s are 9. But what way I put in the 9? I put in the 9 on this side, because that is the numerator that I was dealing with. Yeah? And then you multiply this side here. 4 times 1 is 4. And of course I put in the 4 on this side because that is the numerator I was dealing with. And then the sign, the addition sign, goes in the middle. That's all you have to do. So I'll just do that one more time because it's all you're sounding like if all you're confused. Are you confused? You all are there? Hello? Caitlin, you got that? If I had a third plus 3 over 4, all I need to do is multiply the denominators to get my general denominator, and then I cross multiply like this. So 4 times 1 is 4 plus 3 times 3 is 9. You understand, Scotia? Right. So in terms of a generalized form, we saw that to get the denominator, you had to multiply the 2 denominators. So that is b times d. And then to get the numerators, you had to do this weird cross multiplication thing. So I'll start with the first numerator, a times d. And then you're going to add that to the second numerator, c times b. And this is the general form that will work for all fractions. Everybody understand? Caitlin, you okay? Let me see how all you understand. Now this is the same for when you are subtracting fractions. So if you were subtracting fractions, it would be the same thing. A over b minus c over d. You multiply the 2 denominators, so you'll get b d. Right? And then you do the same cross multiply thing. So I'll start with the first AD, and I'll put it on this side. I'm putting it on this side because that is the side that A was on. You understand that, Scotia? Right? And then I go CB, cross multiply, and then I'll have my negative sign in the middle. You okay, Scotia? Huh? Oh yes, it is AB. Sorry. Thank you very much. So you're okay with it now? Alright, that was always confusing, yeah. Right. So let me see how okay you are with it. These 4 here. You have 5 minutes. This one here. Scotia, are you there? Alright. 1 over 7 plus minus 11 over 7 is the same as minus 11 over 7. And they have the same, the exact same denominator. So you could just say, you know, it's going to be over 7. And you could just say 1 minus 11 is minus 10 over 7. Did you all get that? Alright. Same thing with this. 1 over 3 plus 5 over 3 gives me 6 over 3. Now you can tell that these things could simplify. This is an improper fraction. So what is the mixed number for this? Minus what? One and 3 over 7. You okay with that, Caitlin? Right. And this here, when you simplify this, what will you get? Yes. Now here is where we're starting to deal with different denominators. So we operate just like how we were operating before. With the generalized form, it will work for all fractions, that generalized form, right? So this is really negative 2 over 1 minus 15 over 8. Right? All you had to do is multiply your denominators, so that is 8 times 1, and then you cross multiply. So negative 2 times 8, 8 2s are 16, so that will be negative 16 here. Yeah? Because it's the negative 2 being multiplied by 8. And I'm putting it on this side because that is where the 2 was. And then I have 1 times 15. It's 15. And I'm doing a minus there. That's the same minus that was in the middle here. Right? So what am I going to get? Was negative 16 minus 15 is negative 31 all over 8. Am I correct there? Am I not correct? Remember, when they have the same signs, you add them and you keep the sign, eh? Oh, Caitlin, what you do this? Same thing? Did you get the right answer or not? Right. Yes. So we can see here where our algebra problems lie. This is where our problems with algebra lie. What did you guys do, Scotia and Caitlin? What did you do? What did you get for this top number here? You get minus 1 how? Did you cross multiply these two to get negative 16? And did you cross multiply these two to get the 15? But you put negative 15. And then you put the minus there. Yeah. I mean, if it had a negative in front of the 15 again, maybe. Oops. But you could tell that the 15, even though the 15 is technically a negative, I kind of treat it, you know, because it only have one negative, and that is that. Yeah. So no, this is not correct. What is this? 8. This is 15, and the minus there. Right. So this is an improper fraction. Is what? This is an improper. Huh? 8 3s are what? 8 3s are what? 24. So 8 3s are 24, and 7 over 8, and yeah, and you have the negative sign there. Right. So now we're doing this last one here. So this last one here is negative 1 as a fraction. It's going to be over 1 minus 2 over 3. Same kind of business. So I find my common denominator, just multiply 3 times 1 is 3. and then I cross multiply. This is a -1 times 3 is -3, and I'm gonna leave this negative here. Once I put this minus here, that means that I don't have to treat the 2 as negative, simply because whatever comes after is going to end up being negative because of the sign here, right? So same thing that happened up the road there. So now I could just say 2 times 1 is 2. And now I have -3 minus 2. Same signs. So you add and you keep the sign over 3, which is -1 and 2/3. Nice. So at the end of the day, this is the root of all of our problems in algebra. Remember algebra, you might be seeing all of this fancy X thing and Y and P and Q, but those things just represent numbers. And all that we have in maths are numbers and operations. So those things just represent numbers. So you just treat it the same way as you would any other number. If you see algebra with fractions, you treat it the same way. Multiply your denominators and then just cross multiply. So it's time for your weekly torture. And your weekly torture is brought to you by Cricks. It is the vital supply, after all, especially in these. Oh, of course, you know I must give others some torture. But you sign up for maths, right? Well, so your weekly torture is as follows. If you go to your CSEC, you see in the share screen here, you go to classwork. Sorry? Yes, right? So if you look at this welcome thing here, you'll see there's a little welcome video for you to watch. And there's this GeoGebra, but I'm gonna actually put other resources in here. So eventually this thing is gonna be full of resources for you to use, right? But remember, the curriculum starts at the bottom, so we're going all the way to the bottom into number theory. This is your computations assignment. It's due for this Saturday, September 5th. And you click the assignment, you're going to see a lot of questions. Now listen, I am not the kind of maths teacher that going to be giving you 100 questions to do. I'm not that kind of guy, right? But at the end of the day, this stuff that we're doing right now is kind of SCA Form 1 level stuff. And if you having problems with this stuff, then everything else in maths gonna give you trouble. Because everything else in maths is based on this stuff. So at the end of the day, I do the teacher thing, and I really go on and I give you 100 questions. Look at how many questions we have here. Watch on the side here. Real questions. And some of them have answers. This is an answer sheet here. For the addition of fractions, you have answers. And then for the addition of fractions with mixed numbers, you have answers. So if you could, for the division of fractions, you have answers, and that is it. So if you could do all of these questions, then you will be in real good shape. I would understand if you can't do all though, but I want you to do questions from every page here. Even if you can't do all, make sure that you do some from every page. Is that understood? Right. So when we come back on Saturday, the next class is Saturday at 4 o'clock, I believe. No, it's 3 o'clock. Yes, sorry. It is 3 o'clock. It's 3 o'clock. Thanks very much. So the next class is Saturday at 3. So when we come back, listen, I don't mind, even though we have so much work to do, I don't mind spending the time on this topic because it's so important. Everything else that we will do in maths, this topic here of simple basic arithmetic, especially with fractions, is going to affect everything else you do in maths, especially algebra. And I swear to you, Caitlin, I have seen it with you. Scotia, I've seen it with you. I've seen it with Shizzy as well. I've seen it with all of my math students. All of the problems that you will ever have with algebra has come from this. Yeah. So, on Saturday, what we are going to do is we're going to look over some of these questions. So please do the questions. As I say, you don't have to do all if you can't do all. If you can do all, it'll be wonderful. But make sure you do questions from every page. We are going to tackle about 4 questions maybe from each one of those pages. I just want to make sure that you guys understand this stuff before we move forward. So on Saturday, we'll probably spend the first half hour correcting this, and then we will move forward to other computation and number theory topics. Right? So is that understood, Caitlin? Alright, I hope you guys enjoy your weekly torture. I hope you enjoyed your class. Remember, the entire class was recorded, so if you don't understand anything or you want to go over anything, just look in the Google Classroom. I have the recording of the class isn't the problem. Most of the problem has come from uploading the class. Sometimes the classes do upload. So I'm going to try to see if I could upload them tonight so that by tomorrow the class will be in your Google Classroom. Cool? And I will see you all on Saturday. Have a very good night. Scotia, it's lovely seeing you again, and you too, Caitlin. Bye, guys.